number 35. Now, from number 35, when the expression is something like this, okay, and equals to 20, we can pull out the 4 and rewrite it like this. Okay. Now, if this expression were to equal to 20, then ask 4 times what number equals to 20? Well, 4 times 5 equals to 20. So from this information, we're able to conclude that this expression right here must equal to 5, because again, pull out the 4 and the whole thing, this equals to 20, so this expression has to equal to 5 because 4 times 5 is 20, so we know that equals to 5. Now from the other information that's given to us, which is from 7 to 10 of 3 f of x dx, this equals to negative 12. And then using the same trick that we did, if this equals to negative 12, then 3 times what number is negative 12? Well, 3 times negative 4. So then we're able to also conclude that this function equals to negative 4, right? Now we're ready to tackle our challenge. So the question here is, what is the integral represented by 3 to 7 of 11 f of x? 11 f of x, okay? Now we can easily pull out 11 and perhaps view the question in this manner. So what is this equal to? So the first thing we have to do is we have to find what this is, and then we multiply that by 11. Now from the information that we have from above, we know that from 3 to 7 is squeezed between 3 to 10, so why don't we start with 3 to 10? So here's what we know. The integral from 3 to 10 of f can be thought of as from 3 to 7 of f plus from 7 to 10 of f. From the information that we have gathered, we know that this equals to 5. This equals to 5, okay? This is what we're looking for, so leave this alone for now. From the information that we have gathered, this equals to negative 4, okay? So if we try to find this, then we need to add 4 to both sides. And if we add 4 to both sides, then we get 9. Okay, so that equals to 9. Now going back to this question right here, so this is our problem. What does that equal to? So we know that this equals to 9, and so 9 times 11 is 99. So our answer here is 99. Now on the answer key, you might not see an option for 99, but that's actually part of option E. Somehow it got deleted, so I'm going to put that back in there for you. Okay, so that's number 35. Number 36. 36 is the integral of x plus 2 over x squared plus 1 dx. Okay. Now at the first look, you might be tempted to do u substitution, but it's actually not. U substitution isn't going to work. What you have to do is you have to take each term in the numerator and split them up. So this expression right here can be rewritten as x over x squared plus 1 plus 2 over x squared plus 1, because that's the common denominator. So then you need to distribute the integral symbol. So it's looking like two separate problems. So x over x squared plus 1. And then this is after we distribute the integral symbol to both. Okay? You're going to get 2 over x squared plus 1 here. Now, we now have to integrate each problem separately, or each part separately. For the first part, we can use u sub here. So let u equal to x squared plus 1. Then that means that du will be 2x dx. And so 1/2 du is going to do the trick, and that brings that to that. Now we make a substitution, so then our integral now becomes 1/2 du. That gets replaced for x dx, okay? We have 1 over u because that's u. And then when we finish this, we get 1/2 ln of u, right? ln of u plus c. But this is u right here, so that's ln of u. Okay, 1/2 ln of u. So we finished that part, so let's go ahead and finish this part too. Now to do this part is actually not hard. The reason is because this function down here is the antiderivative for tangent inverse. So this is 2 times tangent inverse of x. So we bring that down. Remember that whenever we try to find the antiderivative, we always do a plus c. And there you go. And that's the answer for number 36. And that matches up with option with E as well. I'll double check to make sure it is E. And it is E. Okay. All right, very good. Now notice that, no, we're fine. Okay, so this is E. All right, let's move on to number 37. Okay, number 37. Where's 37? All right, so 37 says a particle moves along with the velocity. So we have a velocity function for number 37, which is 3t squared minus e to the t. And it says what is the average velocity, okay? So average velocity. Now to find average velocity, we would have to, this is instantaneous velocity. Now to find average velocity, when given the velocity function, we would have to find the total velocity, and this is the total velocity from time 0 to 2. This is the total velocity, okay, divided by the time, and that gives you the average velocity. This is looking very much like an average value, right? And it is. It's the average value of the velocity. That's why it's called the average velocity, all right? So average velocity is this because it's the same as the average value. And now we need to find out what this is. So on the side, let's go ahead and evaluate this. Okay. We need to find the antiderivative function, which is t to the third minus e to the t. We will now evaluate that at 2. So when we plug 2 in here, we're going to get 8. When we plug 2 in here, we are going to get e squared, right? Now we need to do the same thing, but evaluate it at 0. So plug 0 in here, we're going to get 0. And when we plug 0 in here, we're going to get, and that's simplified to be -1. So here's what we have, guys. We have this number right here, and we also have that number right there. And the last thing we have to do to compute this is to subtract them. So if we take this and subtract that, so 8 minus e squared minus -1, that becomes a plus. So then this becomes 9, okay? Now that, if that's confusing, make sure you write it out. So 8 minus e squared minus -1, that becomes 9, okay? Write it out and you see that. So here's what we know. We know that this is that piece. So we go up here and we replace it with 9 minus e squared. And then this is just 2, and we're done. That's the average value. That's the best we can do without a calculator. So then that would be option, if we look carefully at our option, that would be option B. Okay? All right, let's do number 38. 38. Oh, 38, now we can use a calculator, which is very nice. It says find the average rate of change. So be careful, okay? So average rate of change, average rate of change is defined to be. So remember, make sure you know the definition between average rate of change and average value. Okay, those things will tend to be kind of confusing. So for our particular problem, the average rate of change is found by taking, so remember our interval was from -4 to -1. So we're going to go f of -1 minus f at -4 divided by -1 minus -4. Okay, so we know that that's already 3, okay? So we're going to go ahead and compute this value right here using a calculator, and then we're going to divide it by 3. So let's pull out your calculator because this is a calculator problem. The first thing we will need to do is we will need to type the function given into the calculator. So if you look carefully, it is e to the 1 over x. I'm going to type it in y1 because it's easier that way. So e to the 1 over x, and then we're going to divide this by x squared. All right, so that's stored in there as in y1. So now I'm going to evaluate that at -1. And the way how you do it nicely is you go -1. You're going to store that as the letter x. So store, and then the letter x. Now that allows you to store -1 into the letter x. And all you have to do now is call out the function that you stored the function in. It was stored under y1, so we access y1, and guess what we get? We get 0.368. So the first guy here is 0.368. Let's subtract that too, and let's try to find the second guy. So the next thing we need to do is we need to take -4, and we need to store it for the letter x again. Var, y var, hit this a couple times. And so this is another way to evaluate functions nicely. So I evaluate that function at -4, and it comes out to be 0.049. So 0.049. Subtract those two, divided by 3. So 0.368 minus 0.049, divide that by 3, and then I get an answer of 0.106, which is option A. Okay. All right, let's go on to number 39. Yeah, 39 says, consider the integral. So we have an integral from 0 to pi over 2 sine of 2x e to the cosine of 2x dx. And the problem tells us if u equals to cosine of 2x, then which of the following is the new integral? Well, if that's u, then du would be -2 sine of 2x dx. So -1/2 du would equal to sine 2x dx. Now, if we make a substitution, but before we make a substitution, why don't we also find new bound? Okay. Now, these are old bounds, so we have to find new bounds. To find the new bound, we start with the u function, and so the old bound is 0. Plug that into the u function here. Cosine of 0 is 1, because 2 times 0 is 0, cosine 0 is 1. We also need to find the new bound at pi over 2. So you have cosine of 2 times pi over 2. That reduces the cosine of pi, and cosine of pi is -1. So you go from your new bound, this is the lower bound, and this is the upper bound, okay? So let's go ahead and make a substitution now. So we have a lower bound of 1 and a newer bound of -1. And then there was a -1/2 du, so -1/2 du, and then this is e to the u. Now, the upper bound will always be smaller than the lower bound, so we flip this 2, but we have to change the sign. And so changing the sign and flipping the 2 brings us to something like that. And that matches up with option D, and that's our answer, option D. Okay. Let's complete number 40. So number 40 says, a shampoo drips from a crack, and then the rate at which it's dripping is modeled by this function. One plus t to the 3/2. And it says that if there are 32 ounces in the bottle at time 0, so they give us our initial value, the fact that at time 0 there are 32 ounces. That's our initial value, and it's dripping. So how many ounces are left after 5 minutes, right? So how many ounces are left after 5 minutes? So first of all, we need to find the amount, the total amount that has been removed from the bottle. So that's found by taking the integral from 0 to 5, because it's 5 minutes, of this function, and that will tell us the amount of shampoo that has been removed from the bottle. We're going to use a calculator to do that. So here it is. This is the function. So math 9, and then we go from 0 to 5. 1 divided by parentheses square root 1 plus x raised to the 3/2, and then that should be good with respect to x, and that's going to give us a number. And as you can see, so 2.58 of an ounces has been dripped. Now remember that we started with 32, and then in 5 minutes, that's the amount that has left the bottle. So what is the amount left? Well, it's about 29.416. 29.416. Now 29.416 is not an answer. Okay, so let's check the work and see what we did. Well, clearly I did something wrong, because this is a t and not a 1. So let's go here and let me fix this real quick. So make that an x, okay? And everything looks good. So now we get 5, so we get 32 minus that answer, and it's 26.937, exactly as we, it's one of the answers here, so that would be option A. Okay, so the answer is 26.937, option A, and that's because the total amount dripped, and then subtract that from the beginning amount, that gives us the leftover, so this is the leftover.